So I'd like to welcome up on stage Dr. Dani, professor from KTH. It's a huge honor. This is yours.
Yeah.
You get my permission to go crazy with buzzwords if you'd like to.
Okay, we'll see. So everybody hears me? Yeah, perfect. Okay, so I've been asked to say a little bit about how far we have come in the area of robotics and give you a few examples of things that are happening at KTH. Most of my talk is actually going to be about difficulties. So why don't we have robots, on the shelves in Elgiganten or any other store that actually sells technical appliances? Why does it take so long time? And what can each one of you basically do and think of in terms of advancing the technology in this area and bringing it close to humans? So robots have been around for quite a long time, and most of the robots that are used today, we see it in industries, on market or company floors where there are high volumes being produced in terms of products. So robots are really good in putting cars together, and often the question that I get is, will robots end up doing things that are more advanced that humans can do and so on? And they're already doing this today. So robots can put together a car in 23 hours, and no man or manpower can do that today. And it has been like that for quite some decades. Now, the robots that we see in research labs today, robots I work with, look very different from those robots that we can see in car or manufacturing industry. Robots that resemble humans or humans' appearance in some way, that are off-size humans or children's size, let's say. Robots that are being sent to Mars for exploration, robots that look like animals, and so on. So they come today in all shapes and sizes, but mostly are being used for research. Let's see if this goes on. Application areas, very many. So we can say still classical industry. And then outdoor applications, both for example, search and rescue applications, agriculture. So drones may be today used for actually detecting whether there are diseases in vineyards and things like that. So not all the bad stuff drones are used for. And of course, the service sector, where we see the future growth of robotics actually having the largest potential. Now, what we can say and think of when it comes to the service sector is that for the past 2 decades, there has been actually not so much coming out to the market. Sweden being the first country producing an autonomous vacuum cleaner, Electrolux, being at the market mid-90s, when I actually started my PhD, so almost 20 years ago. And then not so much, again, is easy to buy and has something that has much more complex functionality. But the idea is now for the future to marry the mobility, so something that any autonomous vacuum cleaner or lawnmower has, together with manipulability. So making these robots able of interacting with the environment in the same way as we humans do. So using basically the hands and arms for restructuring physically the environment around us. One thing that we have been saying a lot is that when it comes to the classical industrial setups and manufacturing industry, everything has been always pre-programmed. So you would set up, let's say, a car line, and there are no humans around. The robots are pre-programmed, not able to use sensors like the sensors that we use, like eyes and so on, in order to change or comply to the dynamic environment. Now this is changing. So what we see is that big companies would like to build lines that are more flexible, that can be easily then replanned and rechanged, and that's not something to do, it costs money. So the idea is to have robots that actually observe humans doing certain things, using the visual sensing, the cameras, and basically then restructuring automatically different types of manufacturing lines. That's where now the frontline research is. What are the challenges? So everybody reads newspapers and everybody reads about machines winning against humans with very complex games. It used to be chess, now it's Go, and for an academic such as myself, having a machine planning the moves and winning in a game such as chess is, maybe I shouldn't use the word boring, but it's really easy to do. Now, making robots actually physically play chess with humans, using its body to detect the pieces and move these pieces, this is actually then difficult. And this is one of the main reasons why we don't see robots today, just being out for fun in ELP capitalism. The physical aspect of the world, the fact that the world around us is not structured, that there are many things that we cannot expect the world to be made of, that make this difficult. Please come to the next one. So I just need to do the right number of clicks so that you have all the movies playing. So what do we do at KTH? What do we do in my lab? So we do have all sorts of different types of robots with arms, with legs, robots that don't have arms and legs, and here you see some examples. Many of the things you do in your daily life, you do them without thinking, but they do require lots of experience and lots of mental planning that comes to you very, very naturally just because you are used to do it. For example, cutting bread. I don't know how many of you do that every morning. It's not so popular eating bread anymore, but it's really damn difficult. So you have the ability to use your body very flexibly and to align the body in the right way with the object that you're interacting with. And also, depending on the type of bread, you can choose the right tool or the right knife, will also incline it in the right way and so on. And for that, you use your visual sensing, you use all the sensing that you have in your skin, you use all the sensing that you have in your joints and so on. And this information is actually collected continuously. It comes to your brain, and then the big machine up here is making your body also to move. And you adapt as things change. And this is exactly what we do at KTH. We have people with very many different backgrounds, like people doing mathematics, people also studying behavioral sciences and trying to understand how humans are using the sensory information, and then we program robots, equip them also with different types of sensing modalities to be able to do or execute such difficult tasks. Now, there are many challenges here. Let's see if this should play. Maybe also the 3 volts up there. Let's see if that works out. These are just some of the examples that we have in the lab. So we are looking into physical collaboration with humans. It can be like game playing, but it can be also building robots that can help you to move out from your apartment and move to another one. So instead of using humans doing all this heavy lifting, you would have a robot that would somehow intelligently understand whether and how it should move, but also how it should also take some of this heavy weight from the human while doing compliant motion. So classically, if we are to use a buzzword, we say that robots are to be used for 3D, dirty, dull, and dangerous jobs. And these are exactly some of the examples that we look at. Of course, the challenge is to get the right level of collaboration, physical collaboration. So when humans do something together, we know what is basically the way my body moves and somebody else's body moves, because we have something in the brain that eases that task. Now, if you're supposed to do this physical collaboration with a robot that has a completely different body, now imagine carrying something with your cat or with your dog. It's not so very easy for your brain to perceive what kind of motions an animal can do, and it's exactly the same case when it comes to robots. So often I got the question, so why are you building robots that look like humans or resemble humans? So it's not so very much because we actually want to build a new human, but it's very much because it's easy for the human to perceive what the robot can do. So to enable more natural physical interaction between a robot and a human. Things that are happening and things that we will be seeing, let's say, being used first, because that's the common question that I get. Is definitely autonomous cars, autonomous driving. The technology is already there. Of course, there are still many challenges. Having cars driving in complex terrains, like in Sweden, doing that both in summer when we have lots of sun, and in winter when we don't have any, when there's snow on roads and things like that. Humans are really, really good at that. Plus, the humans are also very good in kind of recognizing or understanding in difficult scenarios, such as a crossroad, for example. If you don't know who's going to move and so on, you can actually use your gestures and understand each other. But what do you do when there is a car on the other side? There's nobody sitting there. How do you use your gestures? How do you understand who moves first and so on? So there are a couple of challenges to be still addressed there. But there is a big opportunity there, because we can do many things. We can do things that are better for nature. We can remove all the cars from the, let's say, Inomtullarna or central part of Stockholm. We can do planning of the traffic in a completely different way. We can build new types of cars that are also maybe targeted towards persons with disabilities and so on. So many things to be developed here. So for those thinking and liking this sector, I can talk to you. Things that or trends that we see also happen when it comes to big companies. So this is one of the companies that has been bought by Amazon. It came directly from a research lab. So the idea was, okay, how can we automate a big storage areas? So, everybody orders, I suppose, something through Amazon. You build your list, you send it in, and then something magical happens there. So before it used to be that people ran around, they fetched things, they packed them in and so on, and then Amazon said, well, this volume, we need to do something about it. So they bought a company called Kiva, and they automated the whole storage space. So now you don't have actually people running around, but you actually have shelves in a completely automated way with items coming to humans that still pack them in. So now they said, okay, what's the next step? How do we also automate the process of actually taking things out from the shelf and packing them in? So they established something that's called Amazon Picking Challenge. It started the first time last year. So these are my guys, my PhD students actually preparing for the Picking Challenge. So the idea is you can choose your robot, you can equip it with whatever type of sensors you want, and the idea is, or the team that wins, is basically the team whose robot can actually empty or pick out the most or the largest, highest number of items from the shelf. And it's not easy, when the humans do that, we again use visual sensing, we use lots of tactile sensing and so on, so many of things are happening here. Now, after the challenge, it was last year in Seattle, I was really angry with the winners, and I had some form of a closing talk at the end of the conference, and I said that the winner of the Amazon challenge really sucked. And the reason is that they really sucked, So what they had on the robot was like a vacuum cleaner that was sucking out items from the shelf. While my team was spending lots of time and many months of actually using and having a real hand or two-fingered hand interacting with items. So it says something about the difficulty of the technology still. So the ability of humans of using our hands and interacting with the environment and complex objects is still something robots can't do. And Amazon realized that, and they said, okay, why would we now be investing lots of money and building research around that very difficult topic? We will actually use the research community, have them compete and so on, and then we will employ, the absolute brilliant minds and the teams that win in the company that can just then use the open source software that most of the people nowadays are developing and use it. So the interesting thing then of thinking for the future is that, you know, where the IPs are and what happens with that, who owns the knowledge and so on. And most of the scientific community today develops open source software. Let's see if we can go along. And robotics is also very much about the intelligent, let's say, intelligence. So developing machine learning systems, AI systems that can interact with humans. For me, it's very much doing this with hardware systems, so robots that can actually physically move. But for very many companies, it's about building software that can, in a natural way, interact with humans, either through dialogue or in some other way. So what we see today are companies such as ITsoft that developed Amelia, which they call a cognitive agent that understands as a human. So you can talk to Amelia. You can do this in very many different languages. And Amelia can understand how you feel from the way you speak, whether you speak very fast and so on. You can also say something about your emotions and so on. So this is an area that grows, so developing basically intelligent types of software. Artificial shrink is also something that is being developed today. So there is also research saying that for some humans, if they went through very difficult and complex happenings in their life, sometimes especially for those that have been out in wars and things like that, it might be easier to actually speak to a computer or to a artificial agent rather than another human because of the guilt feelings and things like that. Now this is being tested on soldiers, but I think that it will be also an area that grows a lot because today, apart from just being able to look into humans and see what's happening with the face, you can also measure lots of things. You can measure whether the human rate, the heart rate. You can measure whether the person sweats and things like that. So you can use many more measurements about the state of the human than just by visual feedback. So potentially having a system that you connect to that measures your body state can potentially give you better help than just somebody that looks at you. This difficulties. Of course, the interaction between very advanced systems and humans. One reason is that we still don't have robots that completely resemble the sensing of the human, but we also have some additional sensing that robots have that humans don't have. So, for example, we cannot measure distances. When we talk about distances, when we talk about places, we talk very much about different types of labels. So if you are to instruct the robot, or if the robot is to instruct the human where to go or how to find the toilet, you will say, oh, you go out the door and then you go to the right, or no, you just go straight and then to the right and it's the first door on the left. How does the robot understand that? How do you go from labels to something that you can measure, because robots do measure things? So this is, I think, very interesting field because it has to do also very much with how do we use the natural language or natural dialogue, and it has, I'd say, there are lots of development still to be done. Easy things. When I ask you what is this, it's not a tricky question. What's this? Frying pan. Okay, good. What is it now? So there's lots of discussions about big data, how we label sequences, how do we extract knowledge from everything that is on the web. This is just one example. For some people, this might be a right example. For some people, it might be a wrong example. And also, if the robot has this as only example of how this object can be used, every time you go for a tennis, it will actually pack a frying pan rather than a tennis racket. Then this is something we don't want. So lots of caution when it comes to using the big data, having the right statistics for actually making artificial decision making is important, and this is exactly what we do today. All the knowledge that is out there that is available for humans. So if you are to prepare a dinner and you make a new dish that you don't know what ingredients it has, how it's made and so on, you will be going and searching on the web for a recipe, for ingredients. You will be looking at YouTube, how certain parts are made. If you are making a very complex cake, and so on. All this knowledge is out there, and it's today being used by robots to actually learn how to do things themselves. Scary. Okay, I'm almost done. A vision for manufacturing industry. This is one of the projects that we have together with ABB. Now you have a human and a human sitting side by side doing something that is very mechanical and potentially also very boring, right? You don't need lots of mental thinking for putting together a mobile phone or something like that because it's very, very mechanical. Research says that sometimes we can do these mechanical things better if we also have something nice to think of in our heads. So if I'm on the left-hand side and I like fashion, and this is my collaborator here who used to be a human who likes football, we don't have anything to talk about. But if in the future my collaborator is a robot that is actually proven to tell me everything about fashion, my very manual workplace will all of a sudden get more interesting. And this is what we look at today. How do we actually comply to the needs of the person that you collaborate with? And it does not need to be physical collaboration. It can be actually only dialogue, mental collaboration, and so on. And this is my last slide. I see you wait there. I don't know how much time I have. We can turn off good, thank you. So,
a robotic co-collaborator? When can we have that?
Yeah, well, soon. Somebody just needs to invest money. That's why I'm here.
Classic.
But anyway, so just to tell you, even if today we can actually, and there are robots that are, Arnold Schwarzenegger, the Terminator. This is actually from Boston Dynamics, what you see here. It's not all that easy. So I just wanted to end up with that slide saying that the company has been bought by Google in 2013. There have been big expectations about building and putting these products on the market. The company is today up for sale. I don't know what the status is really today, this morning, but it has been for sale still yesterday. It says something about the difficulty. So even companies with big muscles, big ideas, and big visions still have difficulty on bringing something like this to the market. And maybe they shouldn't, I don't know, we'll see whether there are ethical aspects or ethical questions about this, but I'm done.
Thank you. Following on our conversation earlier, I think the colossal opportunity of this is somewhat uncomfortable, but hugely exciting.
Yeah.
What brings you up in the morning? What's your personal mission in this?
For me, I mean, I am an educator. I would like to see the next generation of engineers having the idea and understanding of what's ethical, what's moral to do, and how you can actually help people with disabilities, people that are elderly. I mean, to ourselves, in 20 years, when there will be no people to help us to get up from bed in the morning, can I have a robot that does that?
Can I?
I think so.
That is reassuring. Yeah. But the educational piece is interesting, but the ethical piece is interesting as well, which is a talk in itself. Yeah. But just like short, brief end on that. How should we be thinking about the ethical aspects of the Robolution?
Well, there are many things, and one can talk about this for hours. I think that, of course, as an engineer, you always need to make sure that you verify your software, that the hardware is safe, and so on. But there is also aspect of the usability. I mean, all advanced technical solutions can be used for both good and bad things, and it's very much about how do you make sure that there is something in the software, that there is something in the hardware that is not so easy to be reprogrammed. And I think that we are going, when it comes to safety, when it comes to safe software, we are experiencing this with banking, business today, and so on, and we are getting smarter. So when we know how to actually make everything that has personal information safe, how do we make safe software and so on, it will be easier for systems like that to also make it safe.
I think you sum it up very well. By personalizing, we're getting smarter, and I think you persify that. Huge inspiration for all of us. Thank you so much for coming and joining us.
Thank you. Good luck.